day of an international webinar. Now it's time to introduce our eminent speaker for this session, Mr. Subham Kharel. He is a doctoral scholar at the University of Texas at Arlington at the Department of Public Affairs and Planning. Over the years, he has actively been involved in urban and regional planning research using remote sensing and GIS applications, qualitative research, and quantitative research techniques. Before joining the PhD program, he worked with several Indian scientists at the Indian Space Research Organization, Bangalore. During his tenure at the institute, he has contributed to the understanding of traffic flow, transportation systems, sanitation studies, object-oriented image analysis, property tax management systems, archaeological mapping, and urban or regional planning. Currently, he works on transportation planning projects. In this presentation, he will explain the importance of automated and semi-automated data generation in urban planning studies. It's a great pleasure to have you here, sir. Now I request Mr. Subham Kharel to take over the session to illuminate us with the speech. Over to you. Thank you.
Thank you so much for the wonderful introduction. I hope this session will be wonderful and you'll get a lot of knowledge from it, from all my experience. First of all, I would like to ask if you all can see my presentation or not. Hello?
Yes, sir.
Okay, thank you. Okay, so my topic for today is I'm going to tell all of you how geospatial technology and remote sensing data will help bridge urban planning issues through different data generation techniques. I chose this topic because in the developing world, data is much of a problem, and it is not much of a problem here, but in the developing world, it's a problem. And to understand different kinds of things, different kinds of phenomena, you need to have data. So how will you rely on accurate data? So that's why I picked up this topic today. So I'm gonna connect urban planning issues. I'm gonna try to solve urban planning issues using geospatial technology. So first of all, I wanted all of you to understand what are the challenges of urban planners and civil engineers today. Civil engineers, architects, and urban planners have, their methodologies, their techniques have evolved over the year. But we are not supposed to come at a halt. We are supposed to move forward. And in moving forward, we need to ensure that our cities are much more sustainable in the sense of 3 E's, which I have mentioned here in blue: the ecology and environment, economy and employment, and equity and equality. If we establish all these kinds of things, keep these things in mind, and try to plan our cities or try to construct our buildings, in that way we can make our cities sustainable for the future. So everyone knows that more than half of the world's population are urbanites, and this number will rise by another 25% by 2050. This was taken from the UN Habitat 2003 report on slums. And so the Habitat report also describes that cities are becoming unjust every day. And this is because there is a large income gap which has fostered inequality, unemployment, insecurity, globalization, and economic instability that is visible in every city, but it varies at different levels. So our main goal is not to kind of keep on constructing buildings or doing previous kind of urban planning things. It's what Pugagliario in 1999 in his uh, in in his book in page number 295 clearly specified that the challenge to civil engineering at the beginning of the new millennium is not to accept the status quo in the role of profession, but to create a new concept of perfection for human habitats in all their components, to develop the ability to integrate beauty, moral excellence, and physical excellence, and to do so in concept as well as in realization. Only then will the civil engineering profession have acquired a new sense of ideal, a standard of perfection to which it can aspire, and the society and that society can legitimately expect of it. So we are supposed to build such cities which are which exactly pertain to these three E's: the ecology and environment, economy and employment, and equity and equality. So moving forward, uh, as I said that there is a data gap. How do you address this data gap? Well, through a lot of my research, I have found that remote sensing and GIS as a very effective tool in addressing this data gap. Uh, of course, in the United States, I don't need much of remote sensing. I rely on GIS applications, but in areas like India or Bangladesh, anywhere else you go in the world, there's no sufficient data. So we need to use newer technologies like machine learning and deep learning and other things that can help us mine data and use those data in the context of our cities, and then try to look at the patterns of how our cities evolve and what's gonna be the consequence of that. So alongside the right, I have taken up a picture from Plans Up, and this picture is just a representation of how we overlay different kinds of layers to analyze things in remote sensing and GIS. So um, this is the category. This is the category and the order of layers that has been used here. So first of all, it's important to understand that what is a GIS. The term GIS was coined by Tomlinson Roger in the year 1968 in his paper, A Geographic Information System for Regional Planning, in which he described what is GIS. So GIS allows us to view, understand, interpret, and visualize data in different ways that helps us explain relationships, trends, and patterns in the form of maps, globes, parameters, and other properties. So before 1990, there was not much development in this field, but starting 1990 to 2000, um, the field progressed a lot. But it kind of stagnated after 2000, and then uh, because we had a lot of data during that time, but we did not know how to use that data. So because of that, Esri developed an online mode for using data called ArcInfo, which helped access data sets like Tiger. Tiger is a line data set that is prepared by the United States, Landsat satellite image, and even LIDAR data. So, with the evolution of that, GIS has been used all over the world now for different kinds of purposes. So, just so recent developments in the field of GIS and its diverse applications have led to its use in fields like transportation engineering, urban planning, civil engineering, and many more. So the picture on the right is I picked this from my paper, and this just explains, access. When you try to, drive around and you try to get accessibility to different points, this picture explains the level of accessibility. So I'll explain this later. So for the second component, I want you all to know what is remote sensing. Remote sensing is basically explained as the science where you try to analyze an image without coming in actual contact with the image, or and then try to extract information about that image. So it is defined as the art of obtaining information about an object, area, or a phenomena by a device that is not in contact with the area, object, or phenomena of the study. So you are clicking the picture from really far away, and you are using that picture to extract the data. So, but how will you extract the data, right? For doing that, nowadays machine learning and deep learning techniques have evolved a lot, and then they have kind of helped us recognize different kinds of spatial signatures, and um, due to that, uh, now automated techniques have been able to classify the satellite images and prepare the data which we can use for you use NGIS applications. So the image on the right is taken from crisp.nus.eu, and it's a research tutorial about how an optical satellite image works. So as you see, the satellite actually clicks an image of the Earth from the, when the sun is at a particular angle, and accordingly, uh, the surface of the Earth radiates different spectral signatures based on which, all these different kinds of objects are classified. So I want to talk about the applications of remote sensing and GIS in urban planning, and particularly civil engineering as well. So there are different applications like I've listed here: the transportation planning and development, urban infrastructure planning and development, urban monitoring and resilience, smart planning, environmental planning and environmental impact assessment, industrial agglomeration studies, equity analysis, urban spatial economics and economical impact analysis, tourism development planning, and agricultural development and economics. So these are the various sectors where uh, remote sensing and GIS can be used. There are more sectors, but in the urban context, I find these sectors to exactly fit there. And there are different kinds of software and data packages that are used, like ArcGIS Pro and ArcMap, the AirDAS Imagine, Snap Sentinel, QGIS, NV, Google Earth, and Ecognition Developer. Out of these, the Snap, the QGIS, and Google Earth are free, and you have to purchase licenses for the others. So I'm gonna try to demonstrate the applications of most of these software packages, as much as I can in this presentation. So now I have I'm so sorry. Now I have a couple of case studies, because I'm not really focusing on the methodology here in this presentation, but I really want to inform listeners about how this technology can actually help. So I'm gonna talk about a couple of case studies here, and then I'll kind of move to my general conclusions, and then we could have a discussion about different things. So um, the first case study, uh, I would like to talk about the use of remote sensing and GIS in transportation engineering, and specifically in navigation in Bangalore. So this project is kind of performed on the ArcGIS platform, and it uses a tool called Network Analyst, which which requires information on the kinds of roads, the kinds of barriers that are in the road, and if the road is one way or two way, and all those kinds of informations, like all those that are represented in the legend here on the first image. So the purpose of developing these kinds of tools are to explain the phenomena of how a car navigates in a city and what is the most optimized path. So to understand that, there are different kinds of modules built in this. So we try to study, first of all map out, which, you want to move from one location to the other. How do you do that, right? So you see the first point 1 and the second point 2 there, right? So you feed in the information about the origin and destination, it's obvious that it maps it out. So uh, if your network layer is absolutely fine, it needs to be working properly. So then you need to add certain kinds of restrictions in this area. Let's say there's a road blockage and we want to find which is the most optimal route as compared to the first one. We just take a we just update the information about the road as blocked, and then we run the analysis, and again we compare it. It looks really different, like it has taken the long path here, but if this was not blocked, maybe it would have taken the shorter path, right? So let's say in the case of a strike, what will you do? How will you travel, right? The system should be able to feed all this information. And how do we do that? By designing different kinds of scenario which can which can tackle this question. So the next one is the closest facility analysis module that is also in there. So it's kind of an extension of the route network planning module, but here you are supposed, let's say I want to reach a movie theater, and I want to go to the nearest movie theater from my car. So I just feed in the information on, just like how GPS works. And so you feed in the information of the closest movie theater near you, and it will show you, it will take you to the closest one, right? The general application of the navigation system, right? What this system kind of evolved into, service area estimation. So what a service area actually means, it is the ability of a person or a facility, person or a car or a train, to actually get access to a certain location. So in this study, our areas for service area estimations were Indian oil, petrol pumps. The reason for this was, Bangalore is a huge city, and you have to, sometimes you have to try to locate uh, the petrol pumps if you do not know its location, right? And your fuel tank may be empty. In that case, you kind of need to think about how do you get to a petrol pump, or how far is it? So in that case, you develop a service area module where these buffers are not created on radial diameters, but it is created more on the aspects of, the road closures and all those things taken into consideration, and the optimization of the route. So here the pink portion actually explains that there are a lot of petrol pumps in this area, while the green portion explains that there are not much of petrol pumps in this area. So if you need to travel somewhere away, you need to reach the pink station first. You need to get it refueled, and then you need to travel, right? That's a general idea about it. So next one is the the route choice decision making, right? And this is this is a very important concept that needs to be recognized by transportation planners and transportation engineers, traffic engineers, that yes, you can travel around the city in buses, but it's really difficult for uh, the buses do not flow along different routes, right? So you need to reach the bus line to catch the bus, and then you need to go to the closest location, near your destination, and then you need to again walk or take an auto to the destination, right? So this kind of modeling, you can actually load in the bus stops and feed in the information of all these bus stops and try to design a module which could explain, uh, which could connect you from your origin and destination. And like I said, the three is, it should be equitable, right? So you must ensure that it's a seamless flow. So if you can connect from your origin to the lane of the bus stop, if you can connect it through an auto or an e-auto, it is much more equitable for low income communities, or these kinds of people who are living in areas which do not have much access. And then again, to the destination is the same thing. To make travel more and more cheaper, these kinds of systems are kind of um, viewed as the future of transportation planning. So the next one is a buffer, which is used to check if why are there so many traffic jams on Bangalore streets. You see the cross, the red cross, those are the traffic signals, and the black boxes, those are the original bus stop real locations. So you realize that when a signal turns red, all the vehicles stop, right? And when the signal turns green, the vehicles move. But what happens in an Indian scenario is that once a signal turns red, cars stop, and then they turn green, they move forward. But because of the presence of bus stop really, really close to traffic signals, the buses start to pile. But buses stop at those signals, and then although the area near the signal is empty, so that what happens is that piles of traffic jams in the area. So in order to resolve that, we offer the suggestion in this project that you need to relocate the bus stop to a certain distance that is outside the buffer, that is the circle you can see in this image. So kind of this way you can design certain strategies, which help traffic engineers and transportation planners to actually understand and evaluate situations using GIS. So I want to move to my next application, that is this is the study of industrial agglomeration. This is also about transportation, and that is in Dallas Fort Worth, Texas. So you must have recognized that I had not added a remote sensing component in the previous case study. So I'm introducing a remote sensing component in this study. So in this study, we used three kinds of satellite images. One was for 2001, the other was for 2011, and the third one was for 2020. The purpose of using these three kinds of satellite images was to figure out if with the development of transportation infrastructure, the does the industries relocate near transportation or not. So like I said, we need to get the satellite image classified in a certain, using certain kinds of machine learning or deep learning algorithms. I'll not go into much detail about that, but I'll really show you the outcomes of that. So this the red the map at the top is the District 3 of Dallas Fort Worth, and The area that you see in red is area that is near the Love Field Airport, and it is really developed or really developing over the years. And so we have to classify these images into different categories. So we classify these images into built-up classes, then suburban and vacant plots, and then vegetation, and then roads. Usually people don't do roads, but we try to attempt this, and this was kind of successful. But still, so the purpose of classifying these three images, 1, 2, 3, 4, 4 3s are 12 times, so that you kind of try to understand the change over the years, right? So in the graph below, you can see the left axis is the area in square kilometers, and the right axis is a controlled, and that's also the area in square kilometers. That's per road, and the x-axis is the time in years. And when we try to plot, let's say the blue one is the built up, right? So 2001, it was 20.5 to something. And then 2011, this built up area increased to 34 point something. And then 2020, it kind of stagnated. It was growing, but kind of came to stagnate. At the same time, when you look at the vegetation plot, it's surprising that the vegetation, kind of increased in this area. You look at the roads kind of increased from 2001 to 2011, and it still increased, but at a slower pace from 2001 to 2020, right? So you could see how we analyze the how we generate data from satellite images and analyze patterns and trends according to that. So like I said, I generated this data using maximum likelihood classification, and that's an image classification technique, and that actually is a statistical method, but the different packages have evolved which incorporates this technique and tries to classify the image based on MLC or different kinds of algorithms. So this one, as I said, I used the data for 2001, 2011, and 2020. So, it takes time for industries to evolve over time, or, buildings to come around industries. So we consider all those roads that were before 2001 as old roads, and all those roads that developed after 2001 as new roads. And we kind of use another inventory which has the information of industry by the year of its establishment, and that data is on point location. So we kind of classify those industries accordingly, like 2000 and after 2000 as old and new industries. And then we calculate the percentage of old and new industries located in that area. And we find that you see the map at the corner, we see that the maximum road area is the ratio of the road area to the industrial area is almost 0 to 2.0. This means that when development in the roads happened, industries migrated to that area. Similarly, you can see the plot on the the left at the end, and it shows this is simple explanation of how with the increase in the road area, the population density in that area increases. So you might have noticed that I have only used one extra source of data for this, that is the census data. But apart from that, I completely relied on satellite images. So you can see the applications of wide applications of satellite imagery in transportation planning and urban planning. So next, I wanted to discuss about this topic because I think it's really important for civil engineers to understand why do we do surveys. we actually do surveys so that we kind of, before starting a project, we kind of analyze that everything is stable, and then everything is stable and it's ready for construction, so you can move ahead with it, right? So I'll show you how GIS and remote sensing can do satellite from surveying from home. So this is called a land suitability analysis, and uh, it dates back to, the last article I have seen it. It's Gottschalk who has written about about this topic, the land suitability analysis. So he describes that, you rank different things in order of their need, and then you kind of generate an index which helps you to understand which land is suitable and which land is not suitable. So for doing that, I pulled in a lot of extra data sources, like the satellite images, the SRTM and Landsat 8 OLI sensor, and then I also used the heat sensor data, and I pulled out data from the OpenStreetMaps, and I used Snap to classify all these images. And we generally need to extract the temperature from the heat sensor and the slope from the DEM digital elevation model. So after generating all these kinds of maps, uh, the other things are, you use the flood map, and then not the flood map, you use the basin map, and then you use the soil map, the geology, and using all those things, you kind of develop a flood vulnerability index. And finally, you also take into consideration the protected areas that need not be touched. So based on all these kind of maps, like I showed in the second image, I think there were different kinds of layers, but here we'll kind of assign values to all these different layers according to their importance. So let's say that we are trying to build an educational institution. So we want this educational institution to be free from traffic. So in that case, we will rank the we'll rank the highways with the areas near highways with heavy traffic as negative, and but we'll also rank those areas which are very very huge, and where roads can be easily built and you not expect much of traffic in that area. So we'll rank that as positive. Similarly, we'll rank all these kinds of maps, and based on our needs, we'll actually kind of combine these ranks to generate a composite image. Composite index, and then you you'll kind of make sure that the composite index that you generated is not biased. Once you do that, there are certain restrictions in certain areas, like these protected areas where you cannot build. So you need to exclude all these areas, and then you need to decide a suitable location for designing your, constructing your school. So this is how land use suitability analysis helps us explain, uh, kind of helps us in surveying the area using satellite image. Next, I want to talk a little bit about this how satellite images helps us explain uh, helps us explain the development of an area. So like I said, we need to generate all these kinds of layers using satellite images. The Cartosat 2S, the list 4 was used in this project, and the ArcGIS supervised classification of ArcGIS was used for classifying these images, and there were certain legacy GIS here layers that we already had, and we use the AirDAS for classification, and we use the ArcGIS for analysis. So we also had the data provided by the city of Trichy on the total number of toilets that were available. And these projected toilets you see on the left are based on the pay based on the population, the certain calculations in Excel, and these are based on those. So you can see on the actual toilets are, the total number of toilets in each ward. The ward numbers are represented in the right side of the image, in the red map. So accordingly, all the wards have been ranked here, and then we have calculated a summary of how many toilets are in that area. And based on the needs that we saw, based on the needs of the population living there, we tried to compare whether the current number of toilets were actually satisfying the needs of the people, or were there more toilets to be built. So yeah, Trichy was a good city where, it was much more the scenario of the Swachh Bharat Abhiyan was much more uh, good here, and but there were still some areas that needed to be improved. So we got this. I'm sorry, I'll just drink a little bit of water. So using all these kinds of equations that we derived, and different kinds of findings and things, we came to a conclusion about this. And like I said, the land suitability analysis is a really powerful tool. In this study, we mostly relied on satellite images to do the land suitability analysis. So we kind of had to, modify the methodology for computing this. But all these layers that you see on the top are generated layers, except for the public toilet. And we categorize these layers based on the development, the environmental aspect, and another aspect. And then we generated scores for each of them, and then we kind of generated a composite score, and based on that we offered a development status to see which areas were really developed and which area needed development. So you see that we find that the development in the ward number 4, 52, and 45 was really high, but in ward number 9 and 38 it was really low. All other areas were okay, but they were still, there was still scope for development. So you see how these techniques help us analyze that, which areas should be the target. This is also this study also is important because Trichy is a tourist attracting city, and all these kinds of facilities and development need to be in place to attract tourists and to revive the economy. So that is why it's necessary for us to conduct these kinds of studies. So next one, I would like to move into my another case study that is based on Bangalore. This might be kind of different from what I was talking till now, but okay. So I talked about different kinds of classification techniques and how we generated the data based using different softwares, but I'm gonna tell you about the most powerful software that has ever been launched to do this. So the eCognition developer is the most powerful software that can actually do it. You see the map on the top left, that is the BBMP building plot layer that the BBMP gave us. And the map on the bottom is the map that we generated for update, and we generated and then we updated it with the BBMP plot layer to find the discrepancies in the database. Many of you might be knowing of this thing, and yeah, so the areas that I have highlighted in the black circles, you compare the black circles from the from the first image and the second image, in both scenarios, you will see the difference of, how these layers were actually, just made up something. Somebody drew it and then it was approved. But what was the actual scenario? The satellite image does not lie. So you see, the scenario was that there were certain areas where a lot of number of properties were mapped, but in reality there were no properties in that area. But in different parts of the cities, it looked like there were a lot of there were a lot of vacant spaces in that areas, but they were more mapped as properties, and exactly the opposite as well. So we use this technique called rule-based classification, where you can sit and kind of try to analyze each and every kind of classification that you did, whether it is right or wrong, and then you can kind of remold the things again and again into an algorithm eventually which will eventually look like a long tree. And that is called a rule-based classification, which will finally give us all these kinds of outcomes. So it is mandatory that we go step by step in this thing. So we need to start with water, and then we need to mask that off, and then we need to start with another thing, like likewise. We go on and on and on, and eventually we come to the crux of it. Like, we kind of try to separate different kinds of things, which are much more complex to do in any other software, but this can do this. So once the one of the objectives of this project was to identify high rises in the city, the changing context of buildings. So in certain areas, there were in 2000, 2001, I mean 2011, there were some construction that were just starting. But in the 2020, 2017, 18, those buildings were complete, and they were, those one-story building actually became 4 to 5 story buildings. And it's surprising, but you know, it's not possible for city authorities to kind of regenerate this geodatabase again and again and again and again. So you need to move from this kind of technique to, like I said, the cognition developer, which actually classifies it on its own. So how do we know that how many stories are there in a building that is constructed in some part of the city where we are not aware of, not have been in that part? You see the diagram on the top right. It using a repetitive analysis of the rule-based classification, we generated the shadows of each and every building. And based on, like I showed you the diagram in the beginning, there was a sun, and on the inclination of the sun, the image was captured. So that angle and the length of the shadow helps us calculate the height of the building, which is a pretty simple trigonometrical formula, but we generally don't apply that. But here we try to do that, and that's how we identified high rises in the building. And the conclusion of that you can see in the lower picture, the picture that is bounded by yellow. Those big properties, those tall properties have been extracted, but other properties have not been extracted. Demonstrates the potential of the cognition developer and machine learning and deep learning techniques in in urban planning and civil engineering. So, like I said, these kinds of algorithms, these kinds of things helps us bridge the data gap that actually are present in developing nations. The data gap, like I showed you, it actually helps bridge that gap. Sorry. I talked about all these things, and I wanted to give you all a visual image of how we do that. So I am lucky that I got to work with these kinds of things, and that's why I want to demonstrate it. So you need to, kind of look at the first image that is outlined in blue, and the second image. The first image is for urban areas, and so it has been segmented at a level of 30. And the other one is for a agriculture area, and that is segmented at a level of 15. Segmented means, of course, we are trying to divide the image objects into different components, small components that you can see. Those are boundaries, right? So now based on, like I said, the rule-based classification is best for urban areas. So you kind of start from the lakes. Once you gather information about the lakes and classify it, you kind of use it as a, what do you call that, you kind of fix that it is a lake. So you and then you kind of try to classify the vegetation. Next thing comes in an urban area, you try to classify the urban area. From then or from the urban area, you need to classify out the open spaces or the ground. So uh, using a rule-based algorithm, that is a tree algorithm which you develop by yourself, like I said earlier. So you see in the image just below this, the segmentation level 13 is a blue color thing. This is the lake, and outside the lake is the vegetation, which is in red. And outside the vegetation, there are different categories of buildings that we have classified. The dark gray are those buildings that are really small, but there are many in number, and the white are a little bit bigger number of buildings. The yellow ones are the open spaces, the vacant plots, and maybe these are the grounds, and all these kinds of objects are mapped exactly as we needed it to be for our study purpose. And the image on the right, that is the SVM, the support vector machine classification, which is an automated classification. Um, you just need to train samples. Like I want to separate out this vegetation. So I'll s- I'll kind of try to map. I kind of try to train the machine to learn this image, learn this spectral signature. And once the machine learns it, it will, based on its intelligence, it will try to perform an analysis, and it will try to extract out the features that I want. So you have a look at here, and you have a look at here, the blue image and the image, the SVM image. I would say that the rule-based one is much more better than the SVM because I don't see any buildings around here. This is obvious because it's a machine, and we need to kind of rectify all these mistakes that machines do again and again and again, so you can come to a perfect result. And so that is why for urban planning and civil engineering applications, the eCognition has a special tool called the rule-based classification, which exactly helps you, go down to the point where you need to get the data. So that is how, you know, satellite images helps you in that. Next we come at a much more miniature level that for doing for classifying it for agricultural area, and where we have used different kinds of other kinds of techniques like KNN and FSO algorithms, which are also embedded in the software, the cognition developer, which of course you can use these things for classifying the urban areas as well. But for our purpose to understand the software, we did it like this, but you can use it anyhow you want. So based on whatever we have seen here, and the case studies that we have referred to in this presentation, I would like to offer some broader implications about the remote sensing and GIS technologies. Since this technology, as I said, it has evolved over the years. Uh, it's it's multidisciplinary in nature, so that is why it's important for us to incorporate this technique in different fields, so that based on the information that we can process using these techniques, we can actually answer certain questions about those fields which could never have been, possible to answer before. So eCognition Developer is a really expensive software, and I would recommend that switching to softwares like Snap Sentinel also helps us close the data barrier, which is clear in most developing nations. And there are different there are different areas, different platforms where you can get free spatial data, and the most common ones are OpenStreetMap and DIPA GIS. And if you are in the US, you use the US Census database. For the Indian context, the OpenStreetMaps and the DIPA GIS is the best one. Then there are different freely available satellite images that you can use, like Landsat, the Sentinel-2. I have not seen the latest version of the Landsat, but the Landsat 9 is out, and I hope that it is brilliant and it could answer a lot of questions. And like I said, it's the remote sensing and GIS, along with other tools, are really important in civil engineering because, as you have seen in all these presentations, it helps us answer the 3 E's that I mentioned in the first introduction part of the slide. You need to design cities in such a way that it is feasible and safe and equal for all factions of the society, so that society lives together in harmony. So that is why it's important for us to, it's important for us to engineer our cities so that they are sustainable enough to sustain us and sustain many generations after we die. So using these tools can actually be extremely helpful in moving towards the United Nations Sustainable Development Goals. With having said this, these are my references, and this is my details, and I close my presentation. And I leave it open for questions and answers.
Thank you for the wonderful session, sir. Now it's open for question and answer.
Hello, sir. This is Vaibhav Saini. So, in terms of urban planning and infrastructure, a sustainable solution always poses a dilemma as we end up to a solution which is not economical. So, if a consultancy firm comes up with a solution, how should it be economical so that it's more available to the general population?
Okay, that's a good question, and I am glad you asked that question. Yeah, a consultancy can come up with a solution, but we need to figure out a way how to make it sustainable, right? And it might not be economical for addressing the questions of, addressing the issues of the wider community or the faction community. But there is a way to solve that. Yes, let them come up with a solution, but the innovation that is happening within that area must be done by the people living in that area. It needs to be a community-based innovation and a community-based what do we call that? Community-based area. A community-based area. Like, let's say MS Ramaiah is, I know the campus. I live there. so the MS Ramaiah, the medical hospital is there, and you move ahead. There's an engineering district, right? So that is surrounded by different kinds of shops. Somebody is running a printing shop, somebody is running a restaurant, somebody is running a rent, and somebody is doing all these kinds of things. So in a way that is sustainable, because it's not only addressing the answers of the developing community or the developers who are bringing that thing plan and implementing it, it is also, it, by virtue of its establishment, it is also answering the needs of, most communities living in that area. But my point is that if um, if MS Ramaiah wants to relocate to a slum in Bangalore or in Mumbai, right? The campus in Mumbai should be built from scratch by the slum dwellers, and the all these kinds of miniature miniature businesses should be run by them. So this, in this way, you can let the developers develop as well, and you can let the community develop as well. This is how uh, kind of ensure economical and sustainable development. That's an answer that I have.
I have one other query. In case study 4, you mentioned in smart cities, ArcGIS is mentioned for supervised classification. So any other mode of classification rather than thematic approach? For example, we are using rule-based classification in urban planning.
Yeah.
So why aren't we using it in smart cities?
No, you can use it in smart cities. There is nothing like you can use it in this technique or that technique. I am just trying to explain you guys the different methods by which you can classify a satellite image. You classify all these images using different kinds of algorithms, right? And then you can decide on whatever outcomes you want. The only difference between using ArcGIS and eCognition is eCognition gives you much more accurate results than any other softwares. And if you want to adopt a really what do you call that, sustainable, I mean really cheap option, then Snap is available. It's a free software and it has a lot of algorithms in that, right? So but if you really want to get to the end of it, then you need to move on to this software. That's the answer. You can use it.
But eCognition software, to my knowledge, is more expensive than the other ones.
And that's why I know that it's more expensive and it's difficult to purchase. So that's why, if you do not have that option, you need to rely on softwares like Snap or ArcGIS. I think the correct version will do it, but you still need to rely on that. There is no other option. You have to, kind of purchase this software.
Thank you, sir.
I can't hear you.
Hello, sir.
I'm sorry, I can't hear you.
Sir, hello.
Yeah, hello.
Yes, sir. You have told us about different type of case study. On which basis you have evaluated?
Sorry?
You have told about different type of case studies, like transport engineering or transport impact.
Yeah.
On which basis you have evaluated it?
On which basis have I evaluated it? That's an interesting question. These are parts of different kinds of projects. Some are national projects, some are regional level projects. So they're parts of projects, and I really can't explain that answer. But yeah, we have tested these things. Like you see this GPTIS, right? GPTIS. This is Geospatial Enabled Property Tax Information System. This was tested in Bangalore, and data is completely offered by the BBMP, and this has tax records on almost everyone in the city. And yeah, this has been a success because we are testing it at the ground level. So you need to do that after we complete the analysis in this. So after we finish the analysis, the city authority comes and takes away the database and tries to implement in the city. And after they implement it, we get to know the outcomes of this. So that's how it works. When you work with real-time projects, that's how it works.
Okay, sir. Hi, sir.
Hello.
Actually, I had a doubt when you were explaining the applications of remote sensing and geographic information systems. You actually mentioned the point of equity analysis. So basically, my question is that can you explain in brief what is equity analysis and its use in civil engineering so that it can detail explain?
Yes, sure. So equity means that you are providing somebody, let's say somebody is differentiated by class, right? Somebody comes from a high class family and someone comes from a low class family. And this difference has created an income differential, right? This elasticity in income will kind of make uh, the higher income person, get more benefits of things, and he'll kind of uh, get access to more facilities when compared to this low income person, right? But yes, you cannot go and just simply construct houses for them, right? But there are certain factions of the city that you can design and you can construct uh, so that it can help these taxes. Like, let's say, like I showed you in the first I'm sorry, in the first case study, I showed you this map where there are different bus points located, and a person has to travel from this point to the bus line, and then this person has to reach the destination and go to a different location. But if the travel cost is not cheap, and if there were no, imagine a situation in India where there are no auto, right? And imagine there are only buses in India. Would you Can you even think of people using that buses? People going to those bus stops? No, that's not possible, because you have to walk long distances to get to the route, right? So in an equitable perspective, you need to design the city, you need to construct the city. You are civil engineers, and you need to, vision the city as you not only thinking about the kinds of buildings you construct, but you also think you also um, get into projects like construction of bridges and construction of all these things, right? So this is where urban planning fits in. And the first of all, it's like this. First of all, you need to do a survey, and then you need to bring in civil engineering projects, right? So for starting, you need to do a proper city planning. And once you kind of analyze the city and you see that, okay, this is fine, then you can bring in civil engineering projects. So that's why it's really important for civil engineering. Got it?
Yes, sir, I got it. And I have another doubt. While you were explaining the fifth case study, that is urban monitoring in Bangalore.
Yeah.
Yeah, you raised the point of property tax database updation using images derived from satellite imageries. My doubt is that can we use machine learning techniques in order to update these kind of things, rather than using some data from satellite imageries after a period of time? Can't we use machine learning for this property tax database updation?
See, that's an interesting question, and that's a very good question that you have asked. And I would actually rely on using satellite images because of one and one only reason, that you do not know what is the size of the property, what kind of soil it is based. I mean, what is the size of the property, what is the dimension of the property. You do not know that, right? And you cannot figure it out every time. You cannot go to the field and collect the data. That's not possible. So you can do one thing. You can use the satellite images, and you can use machine learning algorithms on that, to update the database. Let's say we consider 10 to 20 years of satellite images, and then we want to update this database. Yeah, it's possible, but you need to, of course, you also need to incorporate the records of the tax from the government. And if you do so, then it's possible. Yes.
Thank you very much, sir.
So here is the question from the participant Kannadasan.
Oh.
How we can use geospatial techniques in transportation in the case of smart cities context?
Okay. So how do we use? Sorry, please repeat the question again.
Geospatial techniques in transportation in smart cities context.
In smart cities context. Yeah. So, we kind of, there are different aspects of transportation, right? I'll just focus on one aspect. Let's say we are trying to study the impact of a smart city project on transportation and its uses, right? Of course, you'll need a lot of data for that, I guarantee you. And uh, but if you have the data on the travel count, the travel speed, and all those kinds of things, you can actually figure out the performance of a transportation system. Before a smart city was implemented, and after before a smart city project was implemented, and after it's complete and developed, you can see the differences in mobility and the accessibility and the impacts of transportation projects. Whatever I was showing you in the beginning is actually the answer to the question that you were asking. Yeah, that's it.
So one more question from Farkan Qureshi. How to calculate the built-up areas, residential areas, or any other areas, and using with software so that we can get approximate values of the same?
Yeah, I think I saw that question, how to calculate the built-up areas, residential areas, or any other areas, and using which software so that we can get approximate values of the same. Okay. So, first of all, I would like to let you know that, the built-up area is whatever construction that has happened in the city. That is considered a built-up area, because there is something built up there. A residential area and the commercial area can be separated on the basis of the size of the area. Like here on the right side, the top bottom right, you see that these huge buildings are apartments or shopping complexes, right? And those small buildings are residential areas. You can't have residential areas that are as tall as the properties that are mapped out here, right? Of course, it is possible in some kind of tall high-rise apartments, but not generally in every case. So, like I said, I explained you this methodology of using which I extracted out the high rises, right? So, now after this, the GIS cannot move forward because it's a satellite image, and you cannot look at the image and say that this is a commercial plot and this is a vacant plot. I mean, this is a apartment plot. That would be wrong, right? So the basic of research is that you need to use two kinds of methods to actually come to a conclusion, and that is you use a quantitative technique and a qualitative technique. So in this qualitative, to answer your question, the qualitative technique would be, after we completed, extracting all these apartments, you go to these areas, or you kind of try to create a point file in these areas, and try to see the Google Earth, what kind of thing is that, and then you classify that according to the residential and the commercial areas, and then accordingly you separate out all these properties. But I think you can use the Google Earth engine for doing that. I'm not well equipped with that, but I definitely can say that this is how you answer this question.
Thank you, sir. We have come to an end now. I request Professor Nisar Ahmed sir to give a vote of thanks.
So this is the end of the session. So first of all, a very warm greetings and good afternoon to everyone. So on behalf of the entire RIT community, staff, faculty, students, so we are very much thankful to Mr. Subham for accepting and delivering a wonderful presentation. Specifically, your highlights on challenges of urban planning and civil engineering, the data-centric approaches, application use cases are very wonderful. I'm very much sure that So our students community, including the faculty, definitely will get benefited with your skills and your presentation. So once again, I'm very much thankful to you, thankful to our IT community, the management, the students for participating in this webinar. Thank you one and all. Thanks a lot.
Thank you, everyone.
So another announcement. So today we have the afternoon session. Start at 2:30 up to 3:45. The speaker is Dr. Syed Hassani. He is a professor in National Forest School of Engineers, Morocco. So please try to attend at 2:15. You should be here. Okay, thank you.
Go to your classroom after you have attended class. A section Niranjan sir is calling out already class. B section and C section are respective class. Okay, you can start. Thank you. Come back at 2:15.
Niranjan sir is already